Hi, my name is Shahan Yang. Welcome to the presentation of the AAVE Liquidation Protection Bot. This is a market make hackathon project. The bot can help protect against liquidation penalties by automatically repaying loans when certain thresholds are met. This project completes a challenge from 1 inch. The diagram here shows a lot of details, with the key steps being highlighted in green. The first thing is we take out a flash loan, and we use that flash loan to repay the user debt. With that user debt repaid, we can now withdraw the collateral. And what we would like to do is to use the collateral to repay the flash loan. Since the collateral token doesn't match the debt token, that can't be done directly. So we use a 1 inch swap to swap the collateral for the debt token, and then that allows us to repay the flash loan. So that all happens in one nice transaction. Now, before the demo, I'd like to call out a key point. So you'll see that right after the flash loan is received, we do this verify signature step. This is important for security reasons, and that will be explained after the demo. On the right-hand side, we see the test fixture. The test fixture forks mainnet using hard hat and deploys the contract, then seeds an initial user by taking out a loan. The service is now started, which allows us to connect to it. That brings up an initially unpopulated information display. Connecting to MetaMask fetches the address and sends it to the server, allowing it to fetch information about the loan and to display it. What we see here is a loan of DAI collateralized using ETH. The current ratio is computed by the server using Chainlink lookups. For demonstration purposes, we will choose a custom threshold smaller than the current ratio to trigger immediate repayment. Clicking the registration button triggers a couple of MetaMask approvals. The first is an ERC20 approval for the contract to withdraw the A tokens. This is needed so that the contract may repay the debt. The approval is a Web3 Ethereum transaction sent via MetaMask. The second approval is an EIP712 message attesting that the user trusts the bot. We will talk more about this later. Once registration succeeds, the bot starts pulling Chainlink price information and immediately notices that the threshold has been exceeded. This triggers repayment. Using a number of complex operations, including a flash loan and a multi-part swap, this costs a hefty 1 million gas. The test verifies that the user debt is reduced to 0 and reports success. In the normal flow of events, the bot initiates repayment by calling the execute function of the repayment executor contract. This triggers the flash loan call, and the lending pool API invokes the execute operation via callback. The callback needs to be handled with care. It is a public method and anyone may call it. A malicious user could potentially trigger premature repayment or even a swap to the wrong token. To prevent this from happening, we use signature verification based on Solidity's EC Recover. The first signature establishes the trust between the user and the bot. The second signature establishes the authenticity of the call data using the bot's signature. We need to do two things before everyone can use this. One, we need to deploy the repayment executor contract to mainnet. And two, we need to create a Docker container for the bot so everyone can use it. Thank you for your attention.